today talking about the bublcam and the rover that I'm building for use with the bublcam. If you watched some of the videos that I recorded yesterday with the camera, you'll notice that I took up a major portion of the screen, and basically the camera was sitting behind me, so all you could really see was the back of my head most of the time. And the idea is that I want to remove the camera operator out of the picture. I'm building a remote control camera rig that's basically a monopod that that I can control tele-robotically through a cell phone or a remote control or a tablet or computer from out of view of the camera. The rig is going to have several cameras around the base that are just going to be low-res cameras and TSC cameras that are going to be used for steerage. And collision avoidance, optical, character recognition, distance sensing, all this kind of stuff. Make sure that I don't drive over cliff edges or downstairs or something like this, and so that if it's moving around autonomously, it won't fall in some place and get damaged, and so that the camera operator can see what the rover is doing without actually watching the video, because the idea is that even the rover, I want to be out of the picture as much as possible. Currently I have the bublcam sitting on top of a monopod that I'm rigging to be in the middle of the rover. It's just like this one here, except that I've inverted it. I've put a weight on the bottom so that this will work on a swivel, so that if I'm going up a slope, the weight will swivel around so that this will stay vertical. And the camera is mounted up here so that I can telescope it out from, say, at 2-foot height, up to the 70 inches, which is the full length of this tripod, or the monopod. So that the camera will be able to sit, up to, 6 or 7 feet up off of the floor, to put it more at eye level, or, slightly higher if I'm doing video recording. Something that's nice about a monopod like this is I can mount the camera here. I can telescope this out, and using it by hand, I can raise it 6 feet above my head, because the camera only weighs well, less than 2 pounds, so it's pretty light, and I can move it out of the way. Up over the heads of the crowds and so on. The camera is being run by an application, on my cell phone here. The Bubl app allows me to change my view of the camera, so that I can see what's going on in the camera. But right now, I can't see the monopod or the stand that it's currently sitting in, which is what I'm shooting for. But I want to make this far more mobile rather than just having a static, like most of the other 360 systems I've seen. One advantage of the bublcam as opposed to like a GoPro system is that, all the video is being captured into one video file. You've got 4 cameras all in one file, that is basically 2 by 2, until it's processed either through the application on the phone or through the Bubl.io website. Then you can load it up to YouTube or Facebook or someplace else, and other people can watch it. It's only as of February this year, 2015, that YouTube has started supporting 360 video and 360 spherical video. If you're watching this video and you cannot do the full 360 view, make sure that you've got any advertising turned off, because sometimes the advertising will remove the spherical view and make it just a flat video image. You also want to make sure, if you're using something like a head mount display, such as the Gear VR that I have over here. You'll be able to, wear the camera, with the phone installed in here, or you'll be able to, view the camera, through the headset here as it's running, and, as you turn your head and look around, you can actually, change your point of view in the picture so that you can see everything that's going on around here. Forgive the mess. I'm a disabled bachelor living alone. My caregiver's, currently on sabbatical. Her boyfriend had a stroke last week, and, she's, taking care of him, which is far more important than, just helping me out. So, I haven't had anyone in here to help me clean up, for a couple of weeks. Now, back to the rover. It started off with a concept. I used to work for a company called Omnidirectional, which is a suburb of, it's in Inglewood, Colorado, which is a suburb of Denver. I was working there through Aerotech Temporary Services, which is a contract temporary placement agency, primarily for technical positions. Omnidirectional was building remote control systems for military vehicles. We were basically creating remote control systems for minesweepers, Humvees, forklifts, tanks, so forth, that you could have go into an area and clear obstacles out of the way without it having the soldiers under fire. That was rather important because it allowed it's far better to keep a soldier safe, and because a tank is far easier to repair or replace than an individual. Now, that was in 2000. In 2002, after 9/11, a lot of the technology got bought up by U.S. robotics and other companies. Now I'm going to take you into my lab room. This is my spare bedroom. You can see all the printer stuff over here on the corner for the 3D printer. But up here on top of the shelf, you'll see a box for the Evolution robotics robot, the ER1. That was one of the first tele-robotic systems that I saw. It basically runs off a laptop. It's got fantastic software, but the robot itself was not very good because it was, sort of X-shaped aluminum bars that were constantly coming apart because the plastic connectors, held up the corners weren't being supported. They kept coming apart and falling out, so it wasn't very stable. But the software, works very good for collision avoidance, optical recognition, character recognition, text-to-speech, speech-to-text, and many other applications that were, really nice. And so I'm hoping to borrow some of the principles from that, for creating the control system for the for the rover that I'm building. Now some of the other things that got me thinking recently is currently there's some other toy robots around. This is a RoboMe by RoboMe. I'm already awesome. Get my ass for maximum awesomeness. Right. This is RoboMe, which is a tele-robotic vehicle from Wowie Toys. You take a smartphone, you place it in here. Using a program that comes with it, you can do remote vision so that you can see through the camera, and using a tablet or computer, you can run it remotely over the internet from someplace else, or you can manually move it here with the remote control. The problem with this is application is limited. I mean, I can't exactly take a monopod and attach it onto here because of the height. It's going to overbalance, and there's no way to really make this thing run around, plus the fact that you wouldn't want to be, I mean, having the camera at kneecap height. So I'll go ahead and turn this one off and go over here to the next one. Now this is the tribot, also by Wowie. I mean, this one is very nice. One of the problems with the RoboMe is that when you're moving it around, you have to turn it to change the direction. If you're using, I mean, the robot like the tribot here. Okay. The tribot has several very cool options. If I can get this remote working, that allows him to move in any direction. I'm going to need to grab the other remote real quick because that one, the battery's something dead. I bought two of these so that I could use one as an experiment for preset control for the robot. Okay, yeah, this one seems to be working. Now, with this robot, it's very nice. Unfortunately, it's $280 new. I'm fortunate that I got a good discount on eBay. Turning him, I can turn him, but I can also move him forward, backwards, and diagonally in any direction. Without necessarily having to turn him. Just by with the Macon omnidirectional wheels here, he can move in any direction. Now using this remote as the basis of the control system for the monopod rover is a very important application is if you're using it for like virtual reality. Now and augmented reality and stuff where you don't want the camera operator in the view. And what's really nice about this is that with the control button down here on the bottom, I can use the remote to move him around. Unfortunately, the space on the tabletop is limited, so that based on which way you tip the robot, the control, he'll move in different directions so that you'll be able to steer him around. But this is also infrared. It's line of sight. It's problematic, and it's very limited. With this system, I can't strap a monopod to him either because it's not going to be, stable enough base. But I can use this as the premise of the rover platform that I am going to build. Okay. Now, let's go ahead and turn him off so we don't have any runaway robots. Bring him back over to the other table so I can show you the solution that I came up with. If you look over here, you'll see that there are parts here from another tribot that I purchased and disassembled. Basically, I was looking for the controls and the wheels, but not the base. And some of the programming on this is sort of gimmicky and stuff. If you look on this guy, he's got two infrared sensors here. He's got two more here in the back. He's got, well, I guess these are the infrared with the purple caps here. He's got two sensors here that are basically sending out like a radar signal so that he can detect objects moving in front of him. But with the wheels and stuff, he can move in any direction. There's a speaker behind here. There's another small motor inside his head that basically all it does is make the ears pop out and the light on top of the head pop up and functionality programming that this particular robot has. I mean, it's good, gimmicky as a toy for kids who like frustrating their friends and their neighbors and all this kind of stuff. If you watch the video and stuff, I mean, it's basically about a young boy harassing his sister and her boyfriend, and basically playing pranks on them. I mean, I'm trying to put this for a much more practical purpose. Now, in the tripod, you've got, I mean, a set of motors, and I mean, the control systems. I'll bring this over and explain the parts in here and how they're going to work in the conversion. Move a couple more things over here. Okay. Now with the robot, I wanted a more stable base, so I bought two pieces of plastic from a local store called Tap Plastics. They're basically 2-foot round discs of plastic. This one here is 1/8 of an inch. This one is 1/4 of an inch. So that one's going to be the base. This is going to be the top. And what I'm going to do is this will provide a much more stable platform for the monopod. Using plastic rods like this, I'll mount these on between the base and the top so that you'll have the height in here. Inside the spacing in here. I may reduce this to a lower height later, but I'm going to make it so that in each 1/6, I guess that there's going to be 6 sections around. There's going to be 3 wheels so that you can move in any direction. I've ordered larger wheels from Vex Robotics. Wheels, motors, and gears. Gearbox assemblies, but they haven't arrived yet. They're not going to be due here for another couple of days. But I'm going to use these for creating the framework around the base. Where there will be 6 rods stretched around the base of this. I'm going to cut the corners all in a taper, and then in each junction there's going to be another rod that's going to stand up like this, so that the other pieces sit on top. I want to make a spacing in between so that the tripod and the counterweight can sit, hang down through the middle and swivel back and forth, and there's enough pendulum space for the thing to move at, like a 25 or 30 degree angle, for like going up slopes and stuff, so that, as this thing is going across the ground, say I'm driving down a sidewalk, there's always curb cuts and for driveways and all this kind of stuff, but you don't always want the camera to be tipping over every time you to reach a curb cut on a sidewalk or going up the slope on a hill or something, so that the counterweight on the monopod is going to keep the camera upright and the video vertical, or the video horizontal. The way the wheels are going to be arranged is that there's going to be 3 wheels that are going to be arranged around here. This is a 2-foot disc. These are 1-foot rods. And I'm using geometry. And yes, few people remember that geometry does have a use past high school. 60-degree angle in each side. And when these are combined together, this is going to make a 120-degree angle. Now with geometry, I mean, you know that if this angle is 60 degrees and this is an equilateral triangle, I mean, I'm going to be able to fit exactly six of them around here with 360 divided by 6, I mean, is going to allow 60 or 6 triangles around, so that I'm going to have, 6 faces. In each face, there's going to be a webcam. There's going to be some motion sensors, so that it'll recognize when it's getting close to objects. One of the things that I may also do on some of the more advanced versions later on is I'm going to make it so that hopefully using a camera like the Intel RealSense camera, that it works similar to the Kinect camera. Here where it uses a motion sensor. You've got a camera, a video camera, that's infrared, and a camera that's a motion sensor. And it'll be able to map stuff around you. With the RealSense cameras, they can both detect objects and they can map the terrain, so that with some of the more advanced robots, you'll be able to actually map the terrain as the robot travels around, so that with the proper programming and stuff, you can make it autonomous, so that it'll be able to find its own way through obstacles and stuff, carrying the camera, so that you can still watch it immersively. And with the monopod, I'm putting it specifically on a round base rather than putting it on a square base, or putting it on top of something like the RC car that I've got here. Originally I was thinking about, I'm going to make one simple version that's just going to be a platform on top of the RC car, so that you can use it sort of like a race car, so that you get the driver's viewpoint from a race car, but it's going to be down low. But again, you're dealing with steering angles and turning angles, so that the viewpoint is going to turn. One advantage of this system is that you can always keep the camera facing in the same direction, and yet move it in any direction. Which is going to be important for interactive storytelling. You can also animate other stuff, in the thing, so that, say you're looking at all of the books and videos and stuff that I've got here. If, say, this is like a store shelf and stuff, you'll be able to click on all of the different items on the shelf, pull up a little pop-up that'll give you information about the item, where to find it, how much it is, all of this kind of stuff, so that if this is being broadcast on a business's website, people can go to the website, look at the video, see what's in the store before they actually go to the store, and they can call the store and say, hey, do you still have this thing available, or how much is this particular item, or do you have, other brands and stuff. Because the difference between shopping on a website and going to a store yourself is that when you go to the store, there's a lot of stuff that you see that you didn't know existed until you got to the store. And a lot of us don't make our decisions as to what we're going to buy until we're actually in the store, because I may be planning one particular meal, and I would find out that the quality of the foodstuffs, especially produce, in the store is not up to the standard that I want to buy, so I may change my mind. If I'm buying it off the website, I'm trusting someone else to pick stuff for me that may or may not be up to the quality standard that I want. And for produce and meat, that is very important, because I hate paying expensive prices for meat, have it delivered, and find out that it's mostly fat and rind. But you'll be able to move this camera up and down, the aisles and stores, and look at all of the objects in there, zoom in and out on the object, click on a little price tag that's on there that'll mean, the information on the stuff. And I mean, in post-production from the video recording, the store will be able to go in and put tags on all of the different items that will move with the items as you're going along. And that will pull up information onto the item that's in the thing, and then maybe have a rotating view so that you can read the label on the can rather than just having a picture of the can. Sitting on the shelf, or like you see in a newspaper ad. You'll actually have a 360 scan of the object that'll rotate around so that you can look at the package, you can look at the angle, you can look at the object at whatever angle you want. You can pull up a 3D model or a virtual view of the object, and then make your decision as to whether or not you want to buy it. If you're, say, hiring a virtual shopper to go clothing shopping for you, if you're a business executive or a professional that doesn't have the time to do the shopping, or you want a fashion consultant to help you make your decisions and stuff, they can take a camera like this to the shop, and you can go through the aisles watching through Skype or something like this. You can communicate with the other person to see what items are currently available in the store, and look at different selections. And you may see something on the racks that you didn't know existed, because it's the other person that's at the store. But this way you can see, oh, I'm interested in that item. Can you pull that out and hold it up so that I can look at it? So that she can just reach over, pull it out, and say, okay, this is Fellowship of the Rings by J.R.R. Tolkien, and this is the CD version. And you can pull up information about the particular products and stuff, and have them hold the stuff out for you to look at. Now with the monopod, there will be several cameras around that are basically going to be down close to floor level, and their purpose is primarily going to be detecting objects that are in the way when the camera's moving, and making sure that there's some place for the platform to move. Where the camera operator is primarily going to be concerned about what's showing up in the bublcam for the 360 spherical video. Now with this application, you'll be able to move the camera around independently of anything else. Say if a business has one of these rovers in their business, a person can just log on to the website and take a virtual tour of the store live over the internet, so that they can do what's called a virtual presence. And they can, it's like projecting your consciousness to that location. If you're using like a headset, like a Gear VR or a Google Cardboard or an Oculus Rift, like the one I've got up there, you can view the video from the remote. And if there's like a monitor on the rover, you can actually communicate back with any salesperson or someone that's there that's saying, okay, I'm doing a virtual walkthrough of a store or business or factory or something else, and you can ask the person with you for information about that. But with the 360 spherical camera, you'll be able to see everything that's going on around you except what's directly underneath you. That way you'll be able to see a lot of stuff that's not necessarily viewable if someone's going around with the traditional camera, so that you're only seeing their box view. On top of the tripod, I'm planning on putting a steady cam. For some of the advanced versions, it's basically going to be a gimbal system, also with a little counterweight that will sit on top, and there will be motors on here so that I can have the camera here, and I can tip this over so that I can look over ledges or telescope it out and look out over cliffs and stuff. And I'll be able to look down, or if you're doing storytelling, it looks like you're looking down off of a balcony or over a cliff or something like this, and you can see what's going on below you without getting that close to the edge. Now with the Steadicam, and the little gimbal here, it's also going to make it so that it's, the camera's, either going to be vertical or you can tip it manually, through the controls on the camera, on the tripod, so that you can control which angle the camera is sitting. With this system, there's going to be, springs connected to the springs and cables connected to the counterweight on the bottom, so that you can manually, tip the monopod over, but it's not going to have the short angle like the Steadicam version will. The Steadicam will also be useful for damping down vibrations. That will be important for if you're going over rough terrain or going through, having this on a car or another vehicle that, may bump, jump over, over gullies or whatever. And, it'll make it, a lot smoother, video recording. Now, with this rover, something that I could have done is, just taken something like this and mounted, here in the middle with the wheels in here. But that's not going to provide that counterbalance, for having the wheels out here on the edges. But a cheap version that I could make is, just doing something like that, which is just having something here, and then having an alternate wheel out here on the edge, just to keep it from tipping over. But depending on this, for the movement. Okay. Now with the camera here, the basic RV that I'm working on, using the components from the tripod. Okay. You've got your control system here, which is basically, up here on the head, it's primarily just lights. You've got, LEDs here for the eyes, the mouth. These are the ones that come out from the ears, and then the light that came out the top of the head. You've got, your left shoulder and right shoulder sensors, for, front and back are, infrared. These are basically going to be spaced evenly around the outer rim of the robot. You've got one sensor here that was the stop sensor, where, with the tripod over here, if you push down on its head, it basically works as a cancellation button. But, I can, so that if I set it to roll autonomously, I can just push down on the top of his head, and it'll cancel whatever action he was doing. But with the cancellation button here, what I can do is I can connect this up to multiple sensors around the edge, so that if it runs into something, or if it, say, runs over an edge and there's no longer any support under one side, it can say, okay, you're getting close to an edge, pull back. Or you're running into an object and pull back. And with the round edges and the wheel space inside, it doesn't have to turn to move, so that I can move it along. I can drive it up to a wall and then literally drive it along, the wall, and then out in any direction. I don't have to just, have space to move it in and out and do three-point or K-turn parking to move the thing around. It will literally move in whatever direction I want, or using the controls, I can move it up to a wall and then rotate it and then move it back out, so that the operator is changing which camera is in the front, so that it's viewed. On this platform also will be a better microphone system, because currently the microphone, there's one mono microphone that's in the camera itself. And it's right under the power button, just on this side of, this main lens here. It doesn't record great audio, especially if you've got wind or other noise around here. If you saw some of the videos that I made yesterday, you could barely hear me. Unless I'm talking directly at the camera. So that, I'm going to create, multiple microphones that are going to be around the base so that when you're watching this, you can get 3D sound. Because, just like watching a stereo movie, you'll have, 3D sound effects where you'll hear stuff coming at you, from a particular location, or you'll hear a noise behind you. Well, if you're running in a 360 environment and you're changing your point of view, how do you know what's behind you? It may be in front of you with the traditional stereo system, so that you have to link the stereo sound to each lens. So that as you turn, you're changing from this pair of microphones to this pair to this pair to this pair, so that there will be 6 microphones around, to record, surround sound, stereo, and then using the principle that's called a sound field. You could determine, which sounds should be playing while you're listening to it, and it will play those sounds depending on, which way in the 360 video you're facing. There's also what's called a light field, and using the light field sensor, you'll be able to, tell how much illumination is coming from any particular direction. There will be, light sensors on the rover that will be able to tell how much light is coming in, and there's 5 connectors down on the bottom of the bublcam that looks like the traditional connectors for hooking it up to a floodlight or a flash from a regular camera. And using that kind of connector, connected with the robot, the operator can turn off and on lights on the robot to illuminate stuff that's out here, so that you're not just totally dependent on external illumination for what's coming on. You can also provide some illumination from down here without blinding the cameras. So there's lots of stuff that can be done. I'm just talking about the principles. I haven't started cutting into this and learning it because I really want to wait until I get the make-em wheels. I want to avoid having any copyright or intellectual property conflicts with Huawei or anything or anyone else. I'm just using their principles and expanding it out into a more functional application. So you can, see, the purpose of this video is so that you can get a general idea of what I'm working on and where I'm coming from. Now, if you look over here, I don't know if you can see it from down there. You'll see that I've also got a quadcopter here. This is the DJI Phantom Vision 2 Plus, and just like the other cameras, you've got a limited point of view from this camera. Sure, you can pivot it and you can move it around and stuff, but even with this camera and stuff, they're getting the legs in the way. But if I take this camera mount off, put a monopod coming straight down, and the 360 camera is suspended underneath this, and then fly this up, you'll be able to watch, video, 360 around. With just this taking up a small portion in the top of the view. I'd have to, visit flip the video over because the top camera up here is going to be, pointing down rather than up. But, flying this over, say, a farmer's field so that he can see, what his crops look like before he, harvests them, or before he sends a crew out to inspect them, or, sending the rover out into an orchard to, explore the, say like you've got an orange grove or a cherry grove or something like this. Having a remote control on the monopod to, um, uh, adding motors to each segment of the telescoping monopod so that you can remotely raise the camera, up through, the spacing between the trees and stuff, and you can, look down at the trees from any angle, or with a quadcopter being able to view, fly it over the orchard and be able to look down and see, what all the fruit and stuff is like on top of the tree rather than, just looking from the side or underneath it. So there's a lot of stuff that can be done with the camera, and a lot of, other stuff. Speed bumping, underwater exploration, all this kind of stuff. I'm not just going to be working on one RC platform for transporting this camera or other similar types of cameras and devices, but multiple items. Currently the big fad is with the quadcopters and flying copters, because they think flying is great, but with all the drone porn coming from the Middle East, and all the violence and stuff coming from that, people are concerned about their privacy. So I'm focusing primarily on land, on surface, top of water, underneath water. When I took the camera into the bedroom, if you want to scroll back to that point, you'll see a model robot or a model ship that I bought. That I'm also going to build a robotic platform with. With the robot here, or with the ship here. What I'm going to do is this is a model of the Bismarck that I'm disassembling. And you can see the motors here and the battery pack and so forth. And this is a remote control robot. What I'm going to do is I'm going to make it so that I've got two of these side by side with a submersible in between. So I'm basically going to build a catamaran. And with the catamaran, I'll have the camera up on top, to record 360 around on the surface view, and then there will be another camera attached to the submersible, so that will go down, for looking at stuff underwater, so that if you want to do, go to collect, logs and stuff, from the bottom of mill ponds or lakes and stuff like this for, going after some of the rare woods or the sunken logs and virgin woods from the turn of the century, you'll be able to do that. Use the rover to go up to something and add a tag to it. So I'm trying to create tele-robotic platforms that are geared, generally towards the public and to small industry rather than big commercial industries and the military. I'm trying to build this so that it's much more affordable. I'm using existing technology, existing components. I'm just rearranging how they're connected up. Some of the basic rovers and stuff. I saw just a little RC trident rover that was basically about this big. It was about 8 inches on the side. They were asking $800 for it, and that seems a bit excessive. Yes, the make 'em wheels are expensive. These here, I'd say these are about 4-inch wheels, and these go for about $18 each. The 8-inch wheels that I bought were like $28 each. Then you've got, to buy the motors, the mounts, and everything else. That gets very expensive, and just, the motors, the wheels, and the mounts without any electronics, for, an RV is around $500. And, that's a bit expensive, because a lot of it goes into the gear conversion ratio. Eventually I'll be using my 3D printer back here to, print some of my own gearboxes and stuff so that I can bring that down, and then if I can get this into production, I'll be able to, buy, a lot of wheels and gears and stuff in bulk. To drop the cost down. One of the things that I'm planning on doing is keeping as much of the assembly and manufacture in America as I can, because I believe in supporting Made in America. Let me turn this camera again. Granted, a lot of components are going to come from Japan or China or other stuff, but I want to try and keep as much of this, in-home and in America as possible, because I want to promote the growth of American business and of virtual reality, augmented reality, tele-robotics, telepresence. All this technology, I want to keep as much of this here in America as I can, because we're outsourcing far too much, and I want to keep the ideas or promote the growth of ideas and industry, here in the States. Excuse me. If you like this video, please, like it, tag it, friend it, pass it along. I haven't put forth a Kickstarter just yet. I may use this video as part of the Kickstarter process, because at least with this, you can understand the applications and the principles of where I'm coming from. But this is an expensive project, and being disabled and on Social Security, I've got a limited income. I've been buying parts for this for months and years. Some of the stuff that I have here that I'm using in this project, I bought 2 or 3 years ago in preparation for this. I waited 10 months just for this camera to show up after I bought into it on the Kickstarter. I only just got here yesterday. Thanks a lot. If you have any questions, look on my Facebook page, MYRDDINSTARHAWK. It's pronounced Mervyn Starhawk. The DD is pronounced TH. Welsh. Part of my name for the Society for Creative Anachronisms. Been using it for 30-some years. Mervyn Starhawk. You'll find me on Facebook, on Twitter, on MySpace, on YouTube. It's my email address, mervynstarhawk@gmail.com. I've also got Yahoo and Hotmail, but I don't use them very often. If you have any questions, send me a comment, send me an email. Have any suggestions, or if you're here in the South Bay area and want to work on this project, feel free to get a hold of me, because I am looking for others to help me expand on this idea and make this a viable business. Thanks a lot. See you soon.